Hi everyone, this is the third video for section 7.4 on percents. So we're about to start example 5, which is a very long example with a lot of parts. And like I mentioned at the end of the last video, it combines a lot of the concepts that we've gone over so far. So it's a really nice problem to just kind of review things that you may have either gotten wrong on a previous exam or forgotten about. So let's go ahead. So a manufacturing plant requires lengths of wire that are 3 3/4 inches long. And the wire comes in, or you can think about it, it's sold in coils of 48 inches. And so whenever we get this 48-inch long coil, we need to make segments that are 3 3/4 inches long. And we want to know how many of those we can make from one coil. So we're taking a 48-inch coil and dividing it into 3 3/4 inch segments. So this tells us that we have a division problem. So we're taking 48 and dividing it into 3 3/4 inch segments. And remember, whenever we do multiplying and dividing with mixed numbers, you always need to convert it, or it's easiest to convert it to an improper fraction. So this is really the same thing as 48 divided by converting 3 3/4 to an improper fraction. So 3 is equal to 12/4 plus 3/4 is 15/4. And remember, to divide these fractions, we're going to flip the second number and multiply. So we're doing 48 times 4 over 15. And we can think of this 48 as a 48 over 1. And when we multiply fractions, we multiply straight across. So we multiply our numerators to get 48 times 4. We multiply our denominators to get 1 times 15. And then we see if there's anything we can simplify. So I know that 15 is a product of 3 and 5. And you can also see that 48 is a product of 3 and 16. And then we have 4. So we can write these 3's to cancel them out. And 16 times 4 is 64. So this is 64 over 5. So we have that if we take a 48-inch coil and divide it into segments that are 3 3/4 inches long, then we get 64 over 5, which if we convert this back into a mixed number, we can see that 5 goes into 64 12 times with 4 left over. So 12 4/5. So we can make 12 total segments and have 4/5 of a segment left over. So the answer to this question is 12. So we can make 12 segments with 4/5 of a segment left over. So the answer is 12. We can make 12 segments. However, I want to know how many inches I have left over. So we want to know what 4/5 of one coil is. So 4/5 of meaning multiply. So 4/5 of one segment, where one segment is 15 over 4 inches. So this is 4 times 15 over 5 times 4. So we know that 15 can be written as 5 times 3. And then we can cancel everything and just get 3. So the 4's cancel, the 5's cancel. We just get 3. So this tells us that one coil can make 12 segments with 3 inches left over. And that is our answer here. So when we take a 48-inch coil, divide it into segments of length 3 3/4 inches, we get 12 of them with 4/5 of a segment left over, and 4/5 of a segment gives us 3 inches of remaining coil. So although the question didn't ask how many inches were left over? I went ahead and did it there because our next question is what is the percent wasted? So on each coil, 3 inches is wasted because if we have a 48-inch coil and we split it into segments of 3 3/4 inches, then we can make 12, but we have 3 inches left over that can't be used, right? It's too small to be put into another segment. So 3 inches is wasted out of 48 inches total. So we want to know what the percent wasted is. So that's basically just asking what percent of 48 is 3. So this just is our basic percent equation. So we want to know what percent of 48 is 3. So we can set it up. I'm going to use the equivalence of fractions way to set this up. So we can see that P over 100 is 3 out of 48. So 3 is our part, 48 is our whole, and we want to know what percent that is. So you can do this in various ways. So 3 out of 48. Didn't we just have 48 was 3 times 16? Didn't we? Where was that at? Huh, I don't remember. Well, 48 is 3 times 16. Ah, yes, here it was, an example 5. Oh, it was in this very first, sorry. So we had it right here that 48 was 3 times 16. So 3 out of 48 is just 1 over 16. Which we can do this in a lot of different ways. We can just divide 3 by 48, meaning to say you can convert this into a decimal in a lot of different ways, which I think, well, you can convert this into a fraction over 100 or a decimal in a lot of different ways. So 3 over 48 is 1 over 16. And because we know that 16 is 2 to the 4th, we can convert this easily into a decimal by multiplying on top and bottom by 5 to the 4th. So this is 5 to the 4th over, and the 2 to the 4th and 5 to the 4th give us 10 to the 4th, which is 1,000, 10,000, which is 10,000. And we just need to know what 5 to the 4th is. So 5 to the 4th is 25 times 25. 5 times 5 is 25. Carry the 2. That's 12. Put in here. 2 times 5 is, that's done. That's done. 2 times 5 is 10. Carry the 1. That's 5. So this is 675. Another thing to note here, on the second exam, a lot of people didn't multiply correctly because they just didn't add this step correctly. So double check when you do this. I know that it's hard because you don't have calculators, but think about it. How many elementary school classrooms do you see with calculators, right? Kids have to do this on their own, so you should be able to as well. So make sure you double check the things you do. So this is 6, 75, 25. See, I got it wrong too. Double check. It's never a bad thing to double check yourself. So this is 625 over 10,000, which if we just take 625, move the decimal place 4 times, this is 0.0625. Okay, so there are a lot of ways to convert this into a decimal, but this is the way I wanted to do it. Just to kind of remind you that if you have a denominator that has prime factors of 2 and 5, you can convert that easily to something with a denominator of a power of 10, which helps us convert it to a decimal. Okay, so the percent wasted is, if we convert 0.0625 to a percent, 6.25%. Okay, so that is the percent wasted. Okay, so just again to put this in context, on each coil, 3 inches is wasted out of the 48 total inches, and so we want to find what percent. 3 is 6.25% of 48 inches, so on each coil, 6.25% of 48 inches is wasted. Okay, so now the same plant that we started with, the manufacturing plant, we spend $30,000 each year on the 48-inch coils. And we want to know how much money would be wasted. So we waste 6.25% of each coil. And so a proportional amount of money is wasted as the length is wasted. So I'll write that down. So a proportional amount of money is wasted as length is wasted. So if we waste 6.25% of each coil, we're wasting 6.25% of that cost for the coils. So this tells us that 6.25% of our $30,000 is wasted. So we just need to find 6.25% of $30,000. So we can do that using multiplication, right? Of tells us there's an implied multiplication. So it's great that we already know that what 6.25% looks like as a decimal, because we can use that to do this multiplication. So we have 30,000 times 0.0625. Remember, when we're multiplying things with decimals, we just line everything up on the right-hand side. And we just multiply like we normally would. So since 30,000 has a lot of zeros, I'm actually going to switch the order of these things. So I'm going to put 0.625 on top. So 0.0625, 30,000. Okay, let me space out the 2 and that 5 a little better. Okay, so this is the multiplication we're going to do. So the reason I wanted to put 30,000 on the bottom here is because we're just going to have a bunch of zeros, and we really only have to do this multiplication once when we use the 3. So 3 times 5 is 15. We write down the 5, carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 6 is 18. And then that 0, nothing happens. Well, it's a 0 in front, but we don't have to write that. So where does our decimal place go? So we count the number of decimal places in our top number is 4. The number of decimal places in our bottom number is 0. So this product will have 4 plus 0, which is 4 decimal places. So that's our answer is 1875. So this tells us that $1,875 is wasted each year. Because the length of the coil that we wasted was proportional to the money, the percent of the coil wasted was proportional to the percent of the money wasted. So we just needed to find that same percent of the money. Okay. So now, since we want to minimize the amount of money we waste, right? Any company wants to minimize the amount of money that they waste. We want to determine a length of the coil that would result in no waste. So let's think about what we know. So we know that they currently use 48 inches. So 48-inch coils have 3 inches of waste. So what's a really easy way to take a 48-inch coil with 3 inches wasted and make it a different length with no waste? Well, if you have 3 inches of waste and you want 0 inches of waste, what do? You subtract 3. So this tells us that if we take a 45-inch coil, they have 0 inches of waste. So this is a length of coil that has no waste. And why is that? Well, it's because if we took a 45-inch coil and divided it into 3 3/4 inch segments, that would just give us 12 equal segments. And that's because 45 inches is just a multiple of 3 3/4. So truly, any multiple of 3 3/4 would have no waste. This is just the easiest one to see because we take a coil with 3 inches of waste and take those 3 inches off, and that's exactly what we would need. But any multiple of 3 3/4 would have no waste because when you divide it, there would be no remainder. Or if you look at like a mixed number, it wouldn't have a fractional part. Okay, and the last question for this example is if our alternative lengths were 69 inches and 87 inches, would either of those result in less waste than purchasing 48-inch coils? So again, we determined the waste by looking at the fractional part here of if we took 48 inches, divided it into 3 3/4 inch segments, our waste was represented by this fraction 4/5. So we're going to do the same thing down here. We're going to take 69 and 87 and divide it into 3 3/4 inch segments, which is 15/4, and see what happens. So remember, whenever we take this fraction to divide it, we flip the second one and we change our division to multiplication. So this is 69 over 1 times 15, times 4 over 15. 69 is going to be 3 divisible by 3. So we can see this is 3 times 23 times 4 over 3 times 5. Those 3's will cancel. So this is 23 times 4 over 5, which is 23, 4, 2, 1, 9, which is 92 over 5. See, even if you can do it in your head, it never hurts to show your work on the side. First of all, to check yourself and make sure you're doing things right. But second of all, so I can see where you make mistakes, right? Think about it. If you're teaching someone and you want to know where they messed up, it's really hard to do that if they don't write down their thought process. So this is 92 over 5, and we want to write this as a mixed number. So we do 92 divided by, let me write this a little bit taller. So 92 divided by 5. 5 goes into 9 once, with 4 left over. 5 goes into 42 8 times, with 2 left over. So this is 18 and 2/5. Okay, so then we do the same thing again with 87. So this is 87 divided by 15 over 4. So we do the exact same process, 87 over 1 times 4 over 15. 87, what is it divisible by? So you can think through your divisibility rules. So it's not even. Is it divisible by 3? Well, 7 plus 8 is 15. So yeah, it is divisible by 3. So 87 divided by 3. 3 goes into 8 2 times. 27, so this is 23. So 87 is 3. That should be 29. My apologies. So this is 29. So this is 3 times 29 times 4 over 3 times 5. Okay, so the 3's cancel again. So we are now looking at 29 times 4. 9 times 4 is 36. Carry the 3. 2 times 4 is 8. Plus 3 is 11. So this is 11. Oh, I guess I can write that step. So this is 29 times 4 over 3 is 116 over 3. 3 goes into 11 twice. Nope, 3 times. With 2 left over. 3 goes into 26 8 times with 2 left over. I'm sorry, this denominator should be 5. This should be 5. My apologies. I was going to say, that seemed really high. Okay, 116 divided by 5. So 116 divided by 5. 5 goes into 11 twice. With 1 left over. 5 goes into 16 3 times with 1 left over. Okay, there we go. So remember that our fractional part gives us the waste, right? We can get, in this first one, we can get 18 segments with 2/5 of a segment left over. And in this second one, we can get 23 segments with 1/5 of a segment left over. And so what we're really comparing is we're comparing 1/5, 2/5, and up here at the top, 4/5, based off our initial coil of 48 inches. So 4/5 is bigger than 2/5 and 1/5. If you recall, when we talked about ordering fractions, if things have the same denominator, then the numerators are all that you have to order. So both a 69-inch and an 87-inch coil will have less waste than a 48-inch coil. And which one has the least amount? Well, comparing 4/5, 2/5, and 1/5, 1/5 is the smallest. So 87 inches has the least waste. Okay, so this is a really long example, but it was really good. It helped us talk about things that a lot of people did wrong on the exam. This is how I would multiply fractions. I would not recommend just multiplying 87 times 4. Especially on the exam, there were just a lot of big numbers that were hard to simplify. I would recommend factoring the numbers, simplifying before you multiply out. Yeah, so this didn't have too much of the percent problems, really just part B, but they all went together really well. So this is this example. It's how we would really use all of these things pretty feasibly. So if you have any questions on this example, please let me know. But that is all for this section and this video.